So today we are going to do quite a few things. We're going to start by signing up for our Remind app. So this just allows you to get anonymous messages. So what I'd like for you guys to do is get out your cell phones if you haven't done so already. And, hang on. Try to add a class. Give me just 1 second. Let's go ahead and try to pause this. I'm trying to add the class now. I tried to do it before we got here. There we go. Okay, so what I'd like for you guys to do is I would like for you to join via text. So I want you to text this number. So this is the number you're going to text it to. It is the, so you're going to text to this. And the message you're going to text, so that's just the general Remind number. So any of your other teachers that use Remind, you'll also text this to them. And you're going to text this message at Mrs. M-A-C-K-E-R. No T and no space, okay? So just at Mrs. Macker. So again, text to that number, and the message will be that. It should say, welcome to AP Stats 2015, okay? I'll tell you in a few minutes as you pop up if you've been added or whatnot. Thank you, dear. So anybody get that message, welcome to Mrs. Macker, it's AP Stats 2015 yet? Couldn't find the class. Yeah, sometimes you might need to reply with your full name because if your phone is not registered necessarily to you, you might have to reply with your name to be able to do it. Anybody yet? You got it? Okay. So if you can't get it right now, that's okay. But just write this information down because we don't get the best service in this room, and I understand that. So just text me on your way home, okay? But you have two options. If your phone already has your name saved in it, it will just say welcome to the class. If it does not, because you have an old phone, it's somebody else's phone, whatever, it's your parents' phone, it's a recycled phone, then it'll ask you for your name. So you'll have one of the two options. It'll just say welcome, or it'll say reply back with your name. You got a different thing. What does your thing say? Yeah. So what you can do is so that is just a yes. You can save me as a contact message. The problem is, remember, if you save me as Mrs. Mackert in your contacts, which is fine, you can't text me, right? It'll just pop up as that's who you're getting a text from. Okay. Right, so it still doesn't show me that I have anybody, but I think it's just because my phone is not getting service. That's okay, but you guys have this information written down, okay? And you can go ahead and put your phones away once you've done that. I just want to be able to make sure that you do get the information. Who is this? Oh, Aya. This is for you. Okay. So what are we going to do today? So go ahead and put your phones away if you would. You have this written down somewhere if anything else. We're going to be talking about several things, one of which is the measure of two different types of things we're going to describe about graphs, our data sets. We're going to talk about shape and center. Okay. That's okay. So we're going to talk about shape and center, about a given data set. And we're also going to talk about histograms and how to create a histogram, because if you look at your summer assignment, you had to create 2 of them. Do you agree? Okay. And I may or may not have started, I kind of just glanced over your summer assignments just to look for the extra credit points, make sure you attempted every problem. And on some of yours, I started writing some things, like things you're going to need to correct. The summer assignment, again, you did it for just the 10 points possible extra credit. It's over as of now, so if you did not submit it, you don't get any extra credit opportunities. But at this point, you are going to resubmit this assignment on Friday for a grade, where I'm going to grade it for accuracy. So we're going to keep it out today, and we're going to go through it, and I'm going to kind of direct you to several problems through the summer assignment that you might need to go back and fix. Okay? Do you have one? You have? Okay, I just want to make sure you didn't have it out. You should have it out with you today because we're going to refer back to it quite a bit. You also need some paper out probably to take some notes as well. Okay? So let's start by talking about the histogram. Okay? And I'm not sure why the smartboard is not working in terms of tapping it. Okay, so we're first going to start by talking about histograms. And as you guys came in today, I had each of you write down something, a piece of information for me on a Post-it note. And what did you guys do? You guys move this record. Can you move this recording just kind of like off to the corner for me? That's perfect. Okay. You guys had a, well, that isn't pretty. Let's see if I can make it prettier. Try it one more time. There we go. You guys had a Post-it note, okay? And we're going to make a histogram of that information. So tell me what kind of information I will need to create that. What do I need to do? How do I start? How did you start when you guys created histograms on your summer assignment? Yes, sir. You put the data in order, okay? How do I know what Corinne's data is versus what Cameron? No. Name. Cameron, I was right. Okay. Okay. What Cameron's data was versus what Karen's data was. How do I put it in order? How do I know? What should I do first? We should probably figure out some information. No, I agree with you. I don't know what all the, because if you look at the one, I'm referring to question number 1D, for example. So if you just want to kind of look at question 1D on your summer assignment, this is kind of like that, okay? So that information was how long did it take you to get ready in the morning, I think, right? So a little different question. How long does it take you to get from home to school? So I agree. If you look at question number 1D on your summer assignment, you had a list. You were able to visually see all of the numbers, right? Whereas right now we don't know that information, so we're going to have to ask and figure out some information. So should we ask every person, or what do you think is, if we're just trying to start a graph and create what I like to call our bins along the horizontal axis, okay? So I said the word bin. What does that mean? The group, class maybe, I've heard of it being called class, group, bins. What is that? Those of you who read the 10 pages before the summer assignment, those are words that came up. Cameron? It's like the group you're going to put them in. You're going to dump them into these groups. You're going to count. You're going to create a frequency table if you want to and count how many go in each bin or each class. So if you look at the bins on question 1D, they go from 20 to 30, 30 to 40, 40 to 50, et cetera, et cetera. Should we go by tens? Yeah. How do we know? Why do you think maybe tens would not be a good thing? Too many what? There'll be too many bins? I think there won't be enough. But before we can even make that decision, shouldn't we know maybe what the smallest number is and what the largest number is? So we have some sort of idea how to break it down. Would you that be okay? All right, so let's figure out who has a really short distance to get to school in here. Minutes. 5. 7. Okay, so anyone less than 5? 5? 5 is the smallest, okay? No one has like 3, you don't live across the street, you can walk. Really? Okay, so 5 is our smallest, it's fine. Who has a long commute? James, how long? That's not that long. 30 is probably a good one. Anyone longer than 30? So somewhere between 5 and 30 minutes it takes you to get to school. So if I went by bins that were 10 units long, 0 to 10, 10 to 20, 20 to 30, how many bars would I have? 3. Is 3 bars a good amount for us to be able to determine shape and look at things? Probably not. So an ideal is about 5 or more, okay? So kind of keep that in the back of your mind. So what would you suggest we do? 0 to 5, 5 to 10. Okay, I think that's a good idea. So let's start. So I'm going to go ahead and say 0 to 5, 10, 15, 20, 25, and 30. It's up to you what you write down and what you don't write down. This is just like the question that you're doing in 1D, so anything that you didn't do on that question that I'm doing here, I might make myself a note. Does that make sense? All right, so there's a couple other things we need to do before we can actually start graphing. It's probably label some things. Okay, so what are some things I probably need to label? Okay, I'm glad you said it that way. Guess what? In statistics, we don't use the words x-axis and y-axis. Your Algebra 2 teachers were wrong. No, I'm just kidding. It's just, we actually call them the explanatory variable and the response variable, and that's how your textbook will talk about it. Until you get your textbook, we'll just call it the horizontal and the vertical, okay? So on the horizontal axis, we should definitely label. So how should we label that? Time in minutes, because you want to make sure you're talking about the units here, okay? So I'm just going to go ahead and say minutes, because the units are what's important, okay? So we're going to label it in units, minutes, because that's what I asked you to use. Now the time question goes, well, isn't that what I asked you, how long it takes to get to school? So that's going to go in our title. Because every graph, every data display that you create should have a title. I looked at yours on 1D, and very, very few had a title. So if you didn't have a title, maybe I'd add it right now. Okay? So how long does it take to get ready? So you should be looking at your 1D and adding units along your horizontal axis and adding a title. We good so far? I'm still not ready to graph yet. I still have to add something else. What is that? This one, what's that called? Vertical axis, which happens to be the frequency. And we need to label it such. So that's exactly what we're going to do. We're going to create a vertical axis, and we're going to label it the frequency. Units. So whatever the units were is what you're going to use, okay? So frequency, and every histogram is a frequency, is along the vertical axis, and then the units would change, just depends on what you're measuring. Now, because minutes, let's talk about that unit of measure for a minute, is something that is measurable. We call that, it's not discrete. Discrete data would be like you are in 9th grade, you are in 10th grade, you are in 11th grade, or you have blue hair, you have red hair. You see what I'm saying? Like it's very different. It's not categories is not really the right word, but let's do a different one. Let's say something that's not measurable. Let's see, what would a different one be? Those were categorical data, it's a little bit different. Let's say shoe size maybe. Like I guess you can do half sizes, but that's really it, isn't it? There's nothing like, it's still like you're wearing 8, an 8.5, or a 9. There's nothing really in between there. Would you agree with that? Whereas time, you can be 30 minutes and 2 seconds. Would you agree? Like there is definite, it's measurable, it's continuous. Does that make sense? So when you have this continuous set of data, this continuous measure of unit of measure, we can create a histogram from that. And that's what we're going to do. So here I'm going to go ahead and pause the recording in a minute. And what I'm going to ask you to do, so hang on just one second, I'm going to ask you to come up and bring your sticky note and come place it on the board where it goes. Okay? So go ahead and pause it for me. Thank you. All right, so there's some issues with how we put our sticky notes up there. I'm going to say that the person that put 30, all the people that put it on 20, all the people that put it on 15, and the one person that put it on 5, and the bunch of people that put it on 10 are all incorrect in their placement. Because this is not a bar graph, remember what I said about the data being continuous, right? So you're either going to be in the bin 0 to 5, or you're going to be in the bin from 5 to 10. You're not going to be on 5. Does that make sense now? Okay? So we're going to have to think about which bin do we go in. I'm sure there were several people that said 5 minutes, so there was one. Were there a bunch of people that said 15? Yes. So where does 15 go? Does 15 go from the 10 to 15, or does it go from the 15 to 20? In other words, I'm asking this question, because this is like the, well, this is what I'm asking. Do I go from, whoops, not sure why that's doing that. 15, oh, you know what? It's not liking the things, I don't think. Well, it'll get over it. 15 to 20, let's take them off. Am I going to include 20? That would be the notation, by the way, for that. Or am I going to, it does not like the little, oh my. All right, I'm going to write it off to the side, okay? It's not liking the, let me write it over here. Sorry, smartboard people, we have no markers. Being not my room, it's making me crazy. So what I mean is this. Am I going to not include 15, but include 20? Or am I going to include 15 here and not include 20? So if I'm going to include it, it has a closed bracket like this. That's what that means. So I'm asking you, where does the 15 go? Yeah, okay. So we have, well, it's going to be 0 to 5, not including the 5. The 5 would go into the next section. So if you had 5 minutes, 5 should be here in the 5 to 10. Understand what I'm saying now? So 10 would go in the 10 to 15. 15 would go in the 15 to 20. Are we okay with what I'm saying? So I'm going to go ahead and pause the recording again. If you made a mistake with your time, come on up and fix it for me. Oops, we have 2 on here. So that's got to be up here. Okay. So I'm going to create a histogram. Now, the smartboard's not liking the sticky notes because this is a different kind of smartboard than the other ones that I did this on, but I'm going to try. And I'm just going to create, no, it's not going to like it. All right, so can somebody do me a favor and write down that between 5 and 10 there were 1, 2, 3, 4, 5, 6, 7. Someone write that down for me. There were 7 in that group. There were 1, 2, 3, 4, 5, 6, 7, 8 in the 10 to 15 group. It's not happy. Thank you. 8. There were 4 in the 15 to 20 group. So 15 to 20, there were 4. Just write 4. And there were 6 in the 20 to 25 group. There were none in 25 to 30, and 1 in the 30 and up. Okay, so I'm going to recreate my histogram. Ideally, there we go. Okay, so between 0 and 5, we had nothing, right? But from 5 to 10, what's the highest number we had in our frequency? No. There was 8. The frequency went up to 8, right? So let's try. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 5 to 10, how many did we have? We had 7. All right, ooh, that's not pretty, but pretend. Okay, 10 to 15, we had 8. Is that right? Yep. Notice what I'm doing. There's no gaps between the bars. How many from 15 to 20? 4. How many from 20 to 25? 6. Oops, I went too far. 20 to 25. None from 25 to 30, and then just 1 from 30 to 35, right? Okay. You with me so far? With that, that's my histogram. When you're drawing a histogram, the bars have no space between them because the unit of measure is a continuous unit of measure. Time is continuous, correct? So therefore, there is no gaps between the bars. So if you had gaps on your histogram, it is not a bar graph, then you need to fix that before you turn it in to be graded. If you had anything other on your frequency other than just numbers like this, you'll need to fix that, okay? If your bar's centered around the number, you need to fix that. We okay so far? Okay, so that should be what the histogram looks like, okay? Now, I had no idea ahead of time what your histogram would look like, so I can't really, we're going to just kind of go with it. What's the shape of this graph? If we talked about shape, that is something that you were asked to read about in your summer assignment. So tell me what shape is. What are some words I can use that would describe this data set in terms of shape? Skewed, okay? We'll talk about which direction it's skewed in just a second. But if we're talking about shape, you have two options. You can either be symmetric or you can be skewed. And this one, I agree with you, it is skewed, but I don't agree with skewed left. When you're talking about skewed, you do have to give a direction. It's either skewed left or it's skewed right. But the skewness is in the tail. Because the tail, I'm going to kind of draw this, and hopefully it'll go back, but if I was to draw a little line across it, do you agree that this little one person over here, this 30-minute person, has created a tail to the right of the data set? So therefore, it is going to be a skewed right data set. Okay? Now, this one is actually different than the one I created in second block this morning, because in second block we had no gaps. This one has a gap. If you have gaps in your data, then you need to say that, okay? So there is a gap between 25 and 30. So we should say that in our shape discussion, okay? So there is a gap between 25 and 30 minutes. Are there any other words that we could use to describe shape? Any other words that you could think about? I can think of two other ones. Bimodal or unimodal, we call that the modality, okay? Are there any peaks in the graph? I see probably two peaks. Would you agree with that? So it appears as though it could be bimodal. Now, maybe because this peak over here between 5 to 10 and 10 to 15, they're pretty close to each other. So is this one person really, is it strongly bimodal? Probably not. But I would agree that it's definitely not unimodal. Maybe multimodal would be a better way to describe this because it looks to me like there are three peaks maybe. Would you agree with that? So, but modality is definitely something that you would use to describe shape. So I probably would have written that this is multimodal because there were several peaks. Okay? I would have accepted bimodal as well because I agree that it does appear that there are two peaks. Yes, Zachary? Bimodal is 2, unimodal is 1, anything over 2 we simply say multi. Okay? So modality, any gaps, any outliers, this is also a place you would use to describe them. If I ever ask you to comment on the shape of a graph, those are the things I'm looking for. I'm looking for either skew or symmetric, the direction of the skew. I'm looking for are there any gaps or outliers, and what's the modality. The other word's called uniform, and we'll look at that in a few minutes. Okay? Now, so there's always three things that we comment on a graph. Shape, which we just did. Then we're going to comment on center, and then we're going to comment on spread. Shape, center, spread. You don't know anything about spread yet, and you won't until Friday, so that's okay. We'll get to that. But we are going to talk later today about center. Okay? And we'll come back to this question, hopefully, if we have time, and talk about where its center lies. Okay? But any questions on shape so far? We're good? Does it have an outlier? Well, we're going to, because an outlier test is something that you had to read about, and we are going to talk about on Friday specifically. I don't know that it has an outlier, but we have definitely said that it has a gap. So gaps and outliers sometimes can go together. We can't do an outlier test on this because we don't have the quartiles listed and whatnot. If we did, then that would be something we would definitely address. We could say a possible outlier here at 20 to 25, and that would be a good way to describe it as well. So the gap between 25 and 30 or a possible outlier at 30. Either one is okay. Good questions. All right, next page for me. Thank you, dear. So here are three different graphs, okay? And we want to talk about all three of these graphs being symmetric because they are. Hey, how you? Good, why don't you put your head up for me? Frappuccino didn't help, huh? Oh, whose is it? Oh. Would you like the fan on? Come on. Get your head up. All right, these are all symmetric. Okay? So they're symmetric, so that would be something you would say. They're not skewed left, nor are they skewed right. They're all symmetric. So you would have already said that. But you're also going to use one of three other words. You're going to use either unimodal, bimodal, or uniform. Which one is uniform? Middle one. What does uniform mean? The same. So does that mean that if everybody took 20 minutes to get to school, that we would have a uniform distribution? Does uniform mean everybody has to answer the same thing? No. What uniform means is 5 people took between 5 and 10 minutes. 5 people took between 10 and 15 minutes. 5 people took between 15 and 20 minutes. 5 people took between 20 and 25 minutes. In each, uniform means in each class or bin, the same frequency occurs. That's what uniform means. Okay? What would our histogram look like, James, if everybody answered 20 minutes? It would definitely not be skewed. What would it look like? I know you know. Somebody else. I know you know. Somebody else. All right. Tell me what it would look like. It'd just be one tall bar, wouldn't it? Just one tall, that's all it would be. One tall bar. And that's not skewed. That's just really tall bar. That doesn't tell us a whole lot. Okay? And we'll talk more about that situation when we talk about spread, because that wouldn't have a very big spread. All right, so that's a uniform distribution. There's the same number of people in each bin. Which one's bimodal? The what side? The blue one? The right side? Oh, I'm writing blue. Oh, it's bimodal though. Okay, yeah. Bimodal. Don't forget, we're also already saying that they're symmetric, right? So you would have to say symmetric also. And then what would this one be? Unimodal. Sometimes you hear me say mound shape. Okay. Does it look like anything that you've seen before? No one? Normal distributions, yes, which are bell curves, right? Or can be bell curves. But yes, we're going to do a lot with normal distributions later in the year. But these are mound shape, unimodal. We could say either one of those to describe this. But again, you also are saying symmetric. Okay? All right, click on the next one for me, sweetie. Thank you. Uh-oh, did we lose our mouse? Slide it to the right. There it is, okay. All right, so if we're not symmetric, the only other option is going to be a skewed situation. It's relatively skewed, or it could be very heavily skewed. And I've given you 2 pictures here. One of them is skewed right, and one of them is skewed left. Tell me what you think. The left one is skewed left, okay? Because if you look here, the tail is to the left. So that's what we would say. This one is skewed left. And if you just say skewed without a direction, I can't give you credit. You have to tell me the direction, okay? And this one would be what, Maddie? Skewed right, because the tail is to the right, okay? So skewed right. Good. Okay, it's in the tail. It's not going to let me do it. In the tail. Good. This should answer the last 3 questions on your summer assignment. Go ahead and look at it for me. The very last 3. There, I think there's 3 pictures of graphs, and you had to tell me whether they were symmetric, skewed left, or skewed right. So go back and check those last 3. Make sure you answered them correctly. If you need to change anything, now's your chance. If you only said skewed and didn't tell me the direction, add it. Okay? But that should answer those last 3. All right, next page for me. So we're going to go ahead and try a little activity here where I'm going to have you people at your table. I'm going to give this to you. This is a set of pages that we're going to be using both today and on Friday. So I don't want you to lose this piece of paper. But I would like for you to only look at the first page of it for me and then go ahead and keep it and bring it back with you on Friday. But what you're going to do is you're going to talk with the people at your table about these different data displays and the situations by which they might match. Okay? So, you're going to read the scenarios at the top of the paper, and then you're going to match those scenarios with a possible graph at the bottom. So, oh, I'm sorry, Jennifer, I didn't get one. I apologize. You want to come sit over here with this group since there's only 3 of them? Huh? Oh, yes, go ahead and stop the recording for me. Thank you, and then come back over here. You're good, thanks. All right, so this is an exercise that I guarantee you will see again. The first quiz we have on this unit, you will have a very similar exercise where I will give you some scenarios, and then I'll ask you to match those scenarios to graphs. If you notice, none of these graphs have numbers on them. Okay, there's no scale at all. All we're doing is looking at shape, and that's it. And really, we're looking at the histogram shapes that are there, but if you notice underneath each of the histograms, there's a box plot as well, because box plots also show shape. That's hard to say. Show shape, okay? But we're going to talk more about the box plots on Friday. So we're really just looking at the shape of the histograms. So I'm going to kind of go through some of these and hopefully give you some clues as to why not some graphs work and others definitely don't work. So let's start by talking about this first graph, okay? Well, actually, let's do the scenarios first. Let's go to the scenarios. Scores on a fairly easy exam in statistics. Is that going to be a symmetric distribution or a skewed distribution if it's easy? It's going to be skewed, because if it's easy, most people score high. So they're going to be tall bars on the higher scores. Most people are going to score 80s, 90s, 100s. Does that make sense? So the frequency will be taller on the right. Does that make sense? So it's going to be a skewed left situation. So looking at all of your graphs here, are there any that are skewed left? Group 5 and group 7. I'm sorry, graph 5 and graph 7. Okay, so then looking at graph 5 and 7, we need to decide which one makes more sense. Well, it's really kind of hard to tell. Would you agree at this point? It's either 5 or 7. Is there anything that maybe would clearly say it's got to be one or the other right now? The outliers. Why couldn't there be outliers? Or could there be outliers? Well, most likely there's not, because if it's really easy, most people aren't going to do. But I'm not sure we can totally outrule it yet. But I agree with you. It's definitely shady that there's some outliers there. So we're leaning towards graph 5. What I'm going to do is I'm going to say, I really wish I could write on the smartboard. I'm going to say that A is going to be either 5 or 7. I'm just going to kind of write it up there. And maybe when we come up to another skewed left scenario, we can really be clear as to which one it is. So let's go ahead and look at scenario B. Okay, scenario B, the number of months it takes to get pregnant. Well, how would you know, first of all? I have a little bit of experience with that. I have 3 kids, been pregnant 4 times. And I did lose a baby. It's not a big, I mean, it was, it's common. I mean, it wasn't, I'm not going to get into the discussion. It's very early on. Here's the thing, that if you're attempting to get pregnant, something that you may or may not know is that if you're trying, it's very likely that you will. Okay? So what does that mean? That most women will get pregnant in month 1 or 2. So what kind of a graph would that look like?
4.
Graph 4. I agree. It's definitely skewed right. So it's either going to be 4 or 3. Would you agree with that? Okay. So why don't we write that? So this one's either going to be 4 or 3. I don't like, let's use a different color so it shows up. So this one's either going to be 4 or 3. And what did we say about A? A was either 5 or 7. We're just kind of narrowing things down. Let's look at C. Age at death of a sample of 34 persons. Okay. So what's true about that in terms of shape? When do most people die? when they're older, later in life. But is it possible to die early on in life? I mean, there are the horrific, childhood cancers and things like that, buses and faces, I don't know. There's things that happen. Get hit by a bus, I don't know. So, I do this thing with my daughter. I'm like, meet my friend Patrick, and I put my face palmer in the face. Does that mean? Probably, yeah, pretty. Anyway, I don't do it hard or anything. All right. So if the age is 34, at the group of 34 people, we're looking at their ages. Is it going to be a skewed right or a skewed left situation? Which one? Skewed left, because the more people will be old, more people, frequency tall, will be older when they die. So we're looking at a skewed left situation. So that's either going to be 5 or 7 again. Which one looks like the death one? 7, because that's where your outliers occur. That's when you get hit by a bus, or that's when you have the childhood cancers or the whatevers, right? So I agree. So I think we've narrowed it down, haven't we? So we've said that this one, 5 is going to be A, and that 7 down here, you can't see it, but that will be situation C. Okay? Good so far? All right, so I'm going to cross out the ones that we've eliminated because we don't need to be distracted by anything. And let's look at D. I was kind of surprised at how few people got this one. So I'm going to give you some information, and maybe that'll help. Girls and boys have different median heights. Boys are typically taller than girls. So having said that, tell me what the graph will look like. Bimodal. Because there will be a peak at girls for their heights, and there will be a peak for boys at their heights. Okay? So is there a bimodal graph up there? Which one? 1. Very good. So that's going to be our D. Do you see what we have to think about in order to be able to get these graphs to match? You have to think about the variables and how they relate to each other. All right, the last digit in a Social Security number. So we're looking at either graph 2, 3, or 6. What do you think and why? Why 6? Okay, so that's a great, I didn't even think about that, but that's a perfect, there's 10 bars, 1 for each digit. That's pretty good. I think there's 10 bars for all of them, though. Is there? You counted. That's awesome. I didn't think about that. That's actually something to look for. That's awesome. But is there something else we could also think about? The frequency of each of those digits. It's kind of random, wouldn't you say? Meaning that not everybody's Social Security number ends in 7. Not everyone's ends in 4. Okay? In our particular group of 40 students, there might be some that have happened more than others, but they're all kind of about the same. It's going to be at least the most uniform distribution that happens. Would you agree? So which one looks the most uniform? 6. Okay? When I say uniform, I mean that all the bars are about the same height. Now, granted, there's some variation. Remember how we talked about variation last class with the M&Ms? There's some variation in our samples, and so it won't be perfectly uniform, but we're there. Okay? So now we're looking at F. And I'm going to skip this one because I happen to think that's a hard one. So let's look at G. SAT scores for a group of college students. What do you think? Which group? Which graph? Why? Most students score in the middle, SAT score-wise. You have a few lower and a few higher. So, and I hate to say this because there are so many really strong testing student athletes, but I think Sydney Jordans and the people of the world that are amazing. But there are quite a few athletes that wouldn't have made it to college based on just their SAT scores alone if they didn't have that athletic prowess, right? So we have these people down here that maybe had a lower SAT score but are still there. And then we have the Mrs. Mackerts of the world that I'm totally kidding. I'm not here at all. I'm somewhere in the middle too. But, you know, the really smart genius people that score, you know, your perfect scores on your SATs or whatever that are down there as well. But they're rare, and they're few and far between. So I would agree with you that it's mostly a mound-shaped symmetric distribution. So I'm going to agree that this should be a G. Okay? So we're now really looking at A and F. Is that true? So let's decide A and F. And we're either going to look at graphs 3 and graphs 4. Tell me which one you think goes with what. 3 goes with F. I disagree. Did we already pick A? Oh, I'm sorry, not A. It was B and F. I apologize. B and F. My bad. B and F. All right. Thank you. So which one is graph 3? I heard F and I heard B. Let me give you because they're both skewed right. Okay. So here's the problem, or here's what's going to make that determination, and it's very subtle. It says here that these are medal-winning countries. Okay, so what does that mean? In this 2000 Sydney Olympics, there's a few countries that won most of the medals, right? And then there were, you know, every country kind of, you know, whatever. But if the whole group is everyone won at least a medal, why does it have, there'd be no what? There'd be no gaps, because everybody won at least one. Does that make sense? So this one has gaps, doesn't it? So it can't be F. This one has to be F. Did I disagree with that one for you guys? Oh, I'm sorry. I apologize, James. But I agree. 3 should be F. Okay? Did I disagree with you? I apologize. I must have come around and said it wrong. So this 3 is F, and this one is B. Okay, so if you had it right the first time and I told you wrong, accept my apology. Okay? But are we good? Keep this. Okay, practice with it. You will have to do something similar. Now, I might pick some of the exact same scenarios. I might pick similar scenarios. But those are the kinds of questions you want to ask yourself. Could it be a bimodal data set? Is it skewed right? Is it skewed left? Okay? Go ahead and put that away for me. You will need it again on Friday. But go ahead and keep your summer assignment out, and let's take our notes out, and let's talk some specific terms about measures of center. Okay? I know. Work out those wrists, right? Thank you, love. Appreciate it. Need your calculator for this, so if you have your calculator, get it out. Need your calculator. So up to this point, everything that we've done dealt with measures of center. We have a lot of vocabulary that we've added. Skew, symmetric, uniform, bimodal, unimodal, all these vocabulary terms that deal around shape. We're going to kind of switch gears and talk about the second descriptor of a data set, and that would be called a measure of center. Something to point out. There are only 2 measures of center. In middle school, they always taught you mean, median, mode together, didn't they? That's wrong. Because mode is really a descriptor of shape, right? Modality talks about the shape. Are there a couple of peaks? There could be bimodal and 2 peaks. It has nothing to do with the center because the center would be in between those 2 peaks. Would you agree? So modality has nothing to do with center. It's a shape descriptor. What has to do with center, there are only 2, the first of which is called the mean. Okay, you don't have to write everything down that you see here. I'll tell you what's important to write down. The mean is just an average. You know how to find it. You add everything up and divide by the total number of things. We've done that since probably 5th grade. Okay, so that's not an issue. But I'm going to show you some new things about the mean. There's a symbol that we use called X bar. You probably have seen that before. It's called a sample mean when we talk about it from an X bar. Okay, it's called the sample mean. Because if you remember what we talked about last class in terms of a population versus a sample, population means have a different symbol, and we'll deal with that when we get to it. So when I have X bar, I'm very specific. I'm talking about a sample mean. Okay? The mean is what's called non-resistant. It means it can move around, and I'll talk about how that moves in a few minutes. But it can move because if you have an outlier, that mean is going to get pulled down towards wherever that outlier is. I'm going to show you an example of that here in a minute. Okay? But this is important. It is non-resistant and it moves. We use the mean to describe center, because this is a measure of center, when we do not have outliers. So what kind of a shape would it have if there were no outliers or skewness? It would be what kind of a shape? Symmetric. So we're going to use this when the data is symmetric. So the first thing you need to do when you're asked to comment on the shape, center, spread, or describe a distribution, you're first going to determine its shape, and then based on its shape, you're going to look at its measure of center. And if it's symmetric, you're going to use the mean. Next one. You might need to scroll this down just a little bit too, right here. No, this one. That one, there you go. Just so you can see the pages underneath it. Okay, cool. So what I have for us here is some class grades. Back in Algebra 2, we have a grade here, set up some test grades. And I'm looking at them, and I wanted to find the mean. Okay? Now, we all know how to do this. The formula I have up here, you may or may not recognize, but I'm going to talk you through it. What does this little E thing mean? Sum, total. We're adding them. So we're going to add up all our values. That's all that means. I'm going to divide by, what is n? The number of values I have. So that's really all that says. Okay? We're going to sum, and we're going to divide by the number of values. Okay. So it's just a fancy way of saying that. No problem. What I want us to do is do it on the calculator. Okay? So get out your calculators, and I'm going to show you how I want you to enter it. I want you to go to Stat. Find the Stat button on your calculator. You're going to learn to love it, because we're going to use it a lot. So find the Stat button, go to Edit, and then you're going to edit List 1. Okay, you're going to enter them into List 1. Make sure you have a List 1. If you want to clear out the entire list, if you already have values in your List 1, and again, once I get my Wabbit up there, my emulator up there, I have to have someone come and download it for me. It's kind of a pain in the neck. But I can show you this. But if you arrow up so that your L1 is highlighted and press clear, enter, it'll clear the whole list for you. But I want you to enter these values in. Okay? So enter those test scores into your List 1, please. How many values are there? There should be 9, so just make sure that you see that. There should be 9 values. Don't skip any. Did you skip one? Okay. And then once you've put them into the calculator, you're going to go to Stat and then go arrow over to Calc, and you're going to calculate the one variable statistics. Because we do have one variable, it is the test score. So Stat Calc 1 bar stat. And you should find when you do that, the X bar is the first value that comes up, or the mean is the first value that comes up. What mean did you get? 79. Perfect. Anybody need help with getting that? We all got it? No? So, no, you don't want to add them. Don't add them here. You just hit them in. So you're going to hit 91, enter, and then keep going. Okay, so go hit 91, so enter them all in. That's what you do here, and then you calculate. Okay? Good. Good. All right, next one for me, Jennifer. You can look onto somebody else's list if you need to. Okay? All right, so it is 79. That's what we got. But I have a trick for you, and this is going to address question number, I think it's 7 in your summer assignment. So if you'd flip to question 7, this will help answer that question. It's a similar type of question than question 7. Okay? So it says here, now let's assume that a new student enters the class and mean Mrs. Robinson makes him take the test. He scores a 10. What's the new class average? Well, what was the average before? 79. So let's look at the formula that we used. The formula, if you remember, the mean is simply the sum divided by the total, right? Well, the mean was 79. Do you agree? And we had 9 values to get that. Do you agree with that? So all we need to find is the sum of those 9. So how do I find the sum? I'm looking to solve for this sum value. How would I get the sum thing by itself? Multiply by 9. So if I multiply by 9, somebody tell me what 79 times 9 is. 911. So that was the sum of the first 9. But I have one more value got entered, didn't I? 711. Oh, it's like Slurpee Day. Okay, good. Perfect. 711. So that's the sum of the first 9. I have one more that came in. So what would I do with this value here? I'd add it to that, wouldn't I? To get my new sum? So I want a new sum. My new sum would be 711 plus 10, and that would be 721. And then what would I do from there? I'd have my sum divided by my total values. So I have 721 divided by 10, because now I have 10 values, 10 test scores, and I should get a new average of 72.1. Okay? So that should help you with question 7. Okay? Same type of situation there. Do you believe me that it's 72.1? How could I do it on the calculator to figure it out? Could I just add, go back to stat edit on your calculator, and put 10 at the bottom of that list? And then go back and recalculate, stat calc, one of our stats. So put 10 in, and see if it doesn't come out to be 72.1. We're geniuses, folks. We're amazing. Okay? It's awesome. The difference with this question and the one that you have on your summer assignment is with this question, I gave you all of those test scores to begin with, didn't I? And I don't on question number 7. But I didn't even look at what those were to answer the question. I didn't need to know what they were. All I wanted was the sum of the first value. Does that make sense? So you can do that too. This is exactly how you're going to do the problem number 7. And I'm also going to be looking for the work involved. So if you give me an answer with no work and it's unsupported, I won't give you credit. Okay? So number 7, show work. Any questions so far? Ooh, we're running out of time. All right, next question. All right, so we knew that. Now, what was the original mean? 79. And then when I had this outlier of 10, it went down to 72. That's a big change, wouldn't you say? So what does that tell us? That the mean is not resistant. It can move. That's what's meant by non-resistant. When you throw in an outlier, it's going to pull it down to that outlier. That measure of center, it fluctuates. It can change. Let's talk about a measure of center that doesn't move as much. Jennifer, would you click on the next one for me? I'm going to get this fixed, I promise. Okay, let's look at one that is resistant. The median, remember you have 2 options for center. It's either mean or it's median. The median is resistant and therefore can be used as a measure of center when you have outliers present. So if you have a skewed data set or when you have outliers. It is a position, actually. You're exactly right. It's the middle number. It's a position. It's not an average. Okay? So it is the middle number. And just like when you did it in 5th grade or middle school or whenever you learned about mean, median, and mode, you're going to count to find the middle. So let's take that 10 back out of our data set. If you entered it into your stat edit for me, take it back out for me. And I want you to find the median on the calculator. Can you click on the next one for me? Hang on, I'm going to do something. And then come up here. Whoa, da, 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 da. Come up here. I'll come back there and do it. So I don't want to cover something up. I did. I'll figure it out. I'm sorry. All right. Nope. Cover it. Thank you. All right. Let me see if it'll let me scroll it down from up on the smartboard now. Oh! I was supposed to cover up what I wanted you to do. If I tried to find the median with the original way of me putting in the data, by the way, you can do that without putting them in order first. I'll show you. If I used it without putting them in order, like I showed you the answer to do it, but your median would still show up, but it'd be wrong, okay? Because if I'm looking at the middle number, the way I have it written here is 69, right? That ain't the median. I just said ain't. That's terrible. I'm sorry. That is not the median, okay? So I have to order the data first because it's a position. It's the middle, but you have to order them first. The calculator will do that for you. Let me show you how. Okay? To order it, works. Okay? You're going to go to Stat, and then you have two options. Do you see how it says Sort A or Sort D? We're going to sort almost always in ascending order from smallest to largest. So that would be Sort A. So you're going to do Stat, Sort A. But you also have to tell the calculator which list you want it to sort. So which list did we put all of our data in? L1, list 1. L1 is, I think it's second 1. Is that correct? Okay, so make sure you see that, but you're going to tell the calculator to sort it first. Okay? And it will say done when it sorts it. Then you can go back and do your stat calc 1var stats again. You will have to push the down arrow key after you've done your stat calc 1var stats, and your quartiles will show up. Are we okay with when I say quartiles, what that means? Okay? Quartile 1, quartile 2, which is the median, quartile 3, min-max, your 5-number summary. MED, what was the median? 78. And that's correct. Okay? What was the median? 78. Perfect. What if I put the 10 back in? What would the median be? It would go down. It would be, so if I put the 10 in here, wouldn't it be the middle would be somewhere in here? So would it be 77? So it would go from 78 to 77. I mean, it's still going to go down, but it doesn't go down that much. Would you agree? Not like that big jump the mean had to take when you put the 10 in. Good. All right, perfect. So when do we use median? When the data is skewed or there are outliers, right? So when that's the shape we're going to use. All right. Can you go down to the 2 down? I'm running out of time. I don't want to run out. Thank you. This one. All right. So what we're going to do here is we're going to address question number 5. Okay, so get out question 5 for me. Question 5 talks about creamy versus crunchy peanut butter. Okay? So what we want to think about with creamy versus crunchy peanut butter is a couple of things that I need to correct. First of all, we should all know how to draw box plots at this time because that's something y'all did back in Algebra 1. Okay? So I'm not going to really review that so much. That's something I expect you to do. However, there were several mistakes. The first mistake is when you have two different data sets like this. You have one for crunchy peanut butter and one for creamy peanut butter. When you are asked to compare the distributions, you use one scale. One and one only. So you should have had one scale with some numbers on it, and then you'll have one box plot here and one box plot here. I don't really know what it looks like exactly, but we'll say it looks like that. One scale. Not two scales. So if you did two scales, you need to go back and fix that. I'm telling you how to get an A on this assignment, okay? Go back and fix it. One scale. Yep. Has to be on top of each other. Using the one scale. You could do it this way, Boris. You could do the axle, you could do them side by side. Like you could just turn this if you wanted to, but you'd have the scale on the vertical that way. But that's the only way to do it, one of those two ways. Something else I'm looking for is that you write the actual 5-number summary across the top of each one. I don't know what they are. I'm just going to make up numbers. Let's say I have 15, 16, 18, 19, and 20. I don't really know. I'm making stuff up. But you're going to put the 5-number summary across the top. You're also going to tell me which one's crunchy and which one's creamy. So you're going to write over here that this one is your crunchy and this one is your creamy. You're going to label them. We good so far? The 5-number summary is all you need. You need the scale down here. Okay, so this is a different situation. You have a scale, like I would have said 15 and this would be 8. I don't really know, right? And then it's a graphical display, so what else does it need? Well, we have the numbers. It's a title. Okay, so create a title for me. You with me? And then it says to compare them. When we're talking about box plots, we're probably going to use which measure of center? The median, because it's part of the box plot, isn't it? Okay? So when I say compare them, I don't mean the median for crunchy is 15 and the median for creamy is 18. While that's pertinent information that has no comparison, compare words are greater than, less than, the same, similar to. You have to use those compare words. So while I agree that adding the numbers are a good idea, you need to physically compare them. And measure of center is something you should compare. Okay? Compare the medians. Compare the mins and the maxes. Okay? Does one start before one even does one start where the median and the other begins? I don't know. Talk about how they relate to each other. Are we clear with what I'm asking you to do there? So when you're comparing, you're going to compare the shape and the center. Okay? The shape, are they both symmetric? Are they both skewed? Is one skewed left and one skewed right? I don't know. You tell me. Any questions about what I'm asking you to do in question number 5? Okay, let's talk a little bit more about mean versus median specifically. If you'll scroll down one more for me. Okay. Nope. Keep going. All right, when the data is skewed, we say the mean is not a good measure. Okay, let's take an example. We'll say we'll use our Algebra 2 test scores. We had the test scores before.
Drivers, student parking passes are being sold in the security office daily. Cost of the year is $100. Starting Tuesday, September 8th, all students will require to have a pass. Space, however, may be towed.
Hang on, I'm not done, folks. Give me a minute. I'm not done.
September is Library Card Sign-Up Month. Sign-up forms for public library cards are available for your English teacher or in Stonewall Library.
Sorry.
This month you will receive a raffle ticket.
Go ahead and put your calculators back, and we'll deal with this in a minute, Jennifer. If you'll just pause it for me. I want to say one more thing, but put your calculators, you can put them away, put them back for me. Okay, so really quick before the bell rings, when I'm comparing data sets, if I know nothing else other than what the mean and the median are, I can decide whether the data is skewed or whether it's symmetric. And let me show you how I know that. We know that if I look at the before test scores, the mean and the median were very similar. That suggests a symmetric data set. When the mean becomes much smaller than the median, that suggests a skewed data set. Specifically, skewed in what direction? Skewed left because I had a score of 10, right? So skewed left after. So when your mean is less than your median, you have a skewed left situation. What would happen if the mean was bigger than the median? It'd be skewed right, okay? So what is your homework? Your homework is going to be to complete, alter, change, fix any problems that you had on those 8 problems. They will be graded for accuracy, and they are due on Friday. If you're thinking about any of the questions that you looked at, is there any ones that you aren't sure of how to do or address at this point? I will put them on School Fusion for you. Yes, I'll do that here in just a few minutes. Yes, ma'am. Uh-huh. Have a wonderful afternoon, and I will see you guys on Friday. Thank you for your help today.